There we go. Second time is a charm. Let me make sure my okay. This is good. My cable is being a dick. There we go. This is the current PDF I'm developing, which is not here. Set this to fuse. There we go. So this is what we're building. So I'm gonna set a hours. And this is what it used to be. So the OpenSparc T1 chip. If I open my Chrome, look for OpenSparc T1. This is not what I wanted to do. Okay, let's read the Wikipedia page just to see what it's about. So the OpenSparc is an open source hardware project started in December 2005. CPU is implementing the Spark instruction set. This is what we are basing ours off as well. Scalable processor architecture. So it's a RISC based, like RISC-V, but then well Spark. It went from 32-bit. It's 40 years old since it's in production, and 39 since actually shipping. We're currently version 9, which I've downloaded, so we can look into it. Here we have the registers. That's not what we need to figure out right now. Here we go, Oracle. For a Spark M12 and Oracle's Spark M8. It's quite a shame that Oracle just dropped the entire project. Damn, this one went to 2 terabytes. 4x Spark T5s. Is the T5 also open source? Well, that's not the point, is it? So let's finish the... Actually, let's finish the main website. If I can close this. There we go. I'll show what we currently have. And there we go. Let's go to home. There we go. This is the current state of the website. But it's not that done yet, let's say. So let's see what we can actually change to make it look better. And in general more advanced than what it is now. So let's just go through the website and look for what we can possibly change. So it's the navbar, just the branding and some navigation. And then we have bringing OpenSparc back to life. This is our, you would think it's not a CTA, it's just a title, but for us it is a CTA. We don't call to action, but we actually call people to stay on the page and be interested about what we're doing. They have information, open hardware, open future. Then we're not ready yet. Let me figure out. So you have the brand name. So I'm not a HTML programmer, just so you know. So in general we have quite a few things to do. I just can't seem to. This is in the documentation. Hold on, let me get it. And not the documentation, but ours. So in a research notebook, can I not just open like Google LM Studio? Google LM notebook. This is what you want. Try notebook LM. If I can log in at least. There we go, let's create a new notebook. Creating your notebook. It should be fairly quickly. I hope, at least. I have no idea what the fuck is going on. I'm not uploading a file just yet. Let me check out what the fuck the problem is. Dropped frames. Hopefully it'll fix itself. I hope at least. Let me check it out on my phone. Okay. Should be fixed now. Now we can simply continue with uploading source files in a second. But let me first open this. This is a research notebook I made, which will be used for quite a lot of monitoring and just notes. I can actually show the finished one, I think. Yeah, here it is. Let's open it up. If I can at least. Oh, it opens on my second screen. There we go. Oh, I already had it open. There we go. So, what we currently have is just introduction, 90nm production research. And then we have the TOC, table of contents. Let's go down here. This is a project. What's the project? OpenSparc Revive. We want to go, if I want to keep the 90nm technology, but we will pick the Skywater one, the S90LM. If we for some reason cannot get that, we use the Samsung BCD90. So the die size will just be the same as the original. Transistor count will also be 300 million. Target MPW. This is not sure yet. We're still working on figuring out the exact date. Production mask, which will also take quite some time. And then now we're in the research phase as of February 2026. I should be able to show you that it's cost tracking. I can actually upload this document so everyone can access it. Maybe that's the best thing I can do. I don't know if anyone would want this document, but transparency is what we want, so it would help. So let me check. Oh, this is also something holding us down. We cannot guarantee the availability of the 90 nanometer beyond 2028. So if this happens and we cannot access it, we need to change the process size, or just find another way to actually use that process size, the 90 nanometers. Here are the key objectives. And this is just the foundries that we can use if they're still active. And some just status and notes. I should actually put the notes separately. That should make it clearer for everyone, actually, not just for me. Let me check this. Those are just dates which we need to change at some point. Cost tracking. This is definitely gonna be the highest. Design notes. Oh yeah. To get DDR4 support, we also need a lot of work, because the Skywater doesn't have a on-die DRR PHY. So you must remove the original DDR2 controller switch. Trust me, it will suck. Let me check. I got a message. And here we have the modifications we want to do, or the target modifications. Let me check. So the original process is a TI 90 nanometers, but we go to the Skywater one. It is to be decided, or to be disclosed rather. And we don't know which target package we will use. That's something we need to figure out. So I'm actually gonna add a source. I'm gonna upload this PDF to here. There we go. Give this a name. There we go. Alright. So, how do we describe this? Essentially, this is going to be a long message. We want to work on the. So we want to work on the recreation of the OpenSparc T2, T1 processor, and later the T2. Stages and have a large amount of work to be done. Large amount of work to be done. Is this document relevant at all for us? Hold on, I'm gonna continue with this later on. I have something to do.